Good morning, students. In last lecture, we discussed about different pathogens, different microorganisms, and we also talk about their routes of transmission, as well as lab-acquired infections and some data from different organizations. And in today's lecture, we will talk about different biosafety levels and how different organisms are divided into the different levels. So these are four levels according to the severity of the pathogens and according to the nature of the microorganisms. So we will talk about all these four levels. First, what is the biosafety level? So biosafety level is actually a biocontaminant precautions referred to isolate dangerous biological agents in an enclosed lab facility. So you can say these are the different labs according to the nature or according to the hazards of the biopathogens. So these there are four levels. So biosafety level 1 to BSL 4. So these four levels are uh, divided according to the nature of the biopathogens, and these four levels are commonly used in US. So the Center for Disease Control and Prevention, so they specify these levels or they make this distribution. But if we talk about the European Union, so they actually did not use these words BSL1 or BSL4 or 2. So they use these words directives, although the distribution of the microorganisms into the different levels is the same according to the severity, but they use the word directives. And similarly in Canada, they call these four levels are contaminant levels. Okay, contaminant level 1, contaminant level 2, and for example contaminant level 4. So the only they use different names, but the level or the severity as well as distribution of microorganisms or biopathogens is the same into all these three divisions. In this picture, you can see CDC biosafety levels, Center for Disease Control and Prevention. So they distributed these four levels, where BSL1 is showing the low risk microorganisms, while BSL2 have higher, and then the BSL3 has the next higher, and of course BSL4 have high risk microbes or microorganisms. Okay, so the pathogens those fall under BSL4, so they are very severe. Okay, for instance, COVID-19, so it fall under BSL4, and E. coli and some Saccharomyces and some other, the non-pathogenic organisms usually fall under BSL1, and some phytopathogens, those can cause potential injury can fall into. So all these information we will discuss in each level into the coming slides. So in case of biosafety level 1, you can see it can the pathogens those are working in biosafety level 1, so they do not cause a disease in healthy humans. So the humans or the workers, those are working in BSL1, and the pathogens those are dealing with in the biosafety level 1 or in biosafety level 1 labs, so they are not infectious in general. Okay, so although might be they can cause a minimal potential hazard, but it's not like the known or like the well-known infectious agents. What are the requirements or what are the lab facilities we need to work with this biosafety level 1? So we need, of course, a limited, the precautions are limited relative to other levels in this BSL1 level, because this is the basic level. Lab personnel must wash their hands once enter or exit into the lab. Eating, drinking, anything like we commonly discussed before, are not allowed in this lab. And of course, the agents may be performed on standard open lab benches. The open lab benches, we can also work with those pathogens on those. So not like specifically any cabinets or laminar flows or safety cabinets we need for this BSL1 microorganisms. And also the door locks to limit access on the lab is also we need limited, but of course not as too much as other levels. Potential infectious material must be decontaminated before disposal. Of course, this is for all levels, and BSL-1 labs generally used as a teaching spaces for high school or the college students. So once we talk about the other levels, so these requirement goes for the next level also. So what are the pathogens? Those are involved or those are fall under this BSL-1 level. So mostly, as I mentioned before, the microorganisms, those are not or those who don't have like potential to cause the disease. Okay, so they fall under this BSL-1 labs. So E. coli, Staphylococcus, Bacillus subtilis, and Saccharomyces and Cerevisiae, and some other the non-pathogenic microorganisms. So these are non-infectious or not causing the disease, but somehow might be they can cause the disease. But of course, in general, so they are not infectious. BSL-2 is suitable for working those agents, those have moderate potential hazard to the persons or to the environment. So the pathogens, those are falling under BSL-2, uh, can cause moderate potential hazard, or they have somehow some infectious agents. And the people or to work into these labs, we need immunization or antibiotic treatment is available. So it means if somebody got like infection, so it's an antibiotic is available. And of course the persons who start working so they for them immunization, the vaccination is available. Okay, so the additional precautions mean the basic requirement that we covered in BSL level 1 plus additional precautions for this level. So lab persons definitely need specific training to handle certain pathogenic agents, and access to the laboratory is limited, and extreme precautions are taken with contaminated shops, since because these pathogen has a moderate or potential hazard. So of course once we are dealing with the shops, possibly because they can cause the one way transmission into the body of the worker, or those are dealing with these microorganisms. And of course certain procedures in which infectious aerosols or splashes may be created are conducted in biological safety cabinets, since these pathogens have moderate potential hazard. So of course we don't take or we don't want to open or use these infectious agents into open benches, okay, or any other physical contaminated equipments, okay. So if they have aerosols or splashes that we might know, and then we should need to work into the cabinets. So this is about the BSL-2 level, and in the next slide we will discuss about the pathogens those are fall under this BSL-2 levels. The pathogens are those who fall under BSL-2 are the virus, hepatitis virus A, B, and C virus, and HIV virus also, and some strains of E. coli and Staphylococcus and Salmonella. So those are pathogenic, so they can cause the disease. So these organisms or microorganisms, they fall under BSL-2 at a risk associated pathogens. Let's talk about BSL-3, the microbes which can cause serious and potential lethal disease via inhalation route. So this type of work can be done in clinical diagnostic teaching research or production facilities. So so you can understand now in BSL-3 the microorganisms are more dangerous, as well as the requirement will be like more sophisticated. So we need like more requirements, or we need extra precautions. So the additional measures, it means it included BSL-1, BSL-2 requirements plus additional measures. All lab personnel have or provided medical surveillance and offer the relevant immunization, of course, to reduce the risk of any accident. All procedures involving infection materials must be done within a biological safety cabinets. So there is a restriction. Okay, so definitely the pathogens those we deal in BSL3, so must we should work in use a biosafety cabinet. So we will not use open benches or any other the cabinet or like the hoods. Lab persons must wear solid front protective clothing and must discarded or decontaminated after each use. And of course, biosafety manual must be drafted. The protocols should be drafted, and then entrance must be separated from the areas of building. So where unrestricted traffic flow. So of course, authorized persons are only allowed to come and go into these labs. The risk group or the microorganisms involved in BSL3 are Mycobacterium tuberculosis, SARS virus, Rift Valley fever virus, rickettsia yellow fever virus, the West Nile virus, and several species of Brucella. So these are, the more infectious agents those fall into BSL3. The last level of biosafety level is number 4. So of course this is the pathogens are more severe those fall here, and then definitely they can cause a severe disease that can cause also fatal diseases in humans. And of course for this type of the level, so no vaccination or treatment is available. So mostly for instance, the pathogens those are more severe or newly emerged or like novel the biopathogens are fall under this biosafety level 4. Additional precautions including BSL1, BSL2, BSL3 plus these additional precautions, we need a cabinet lab or protective suit labs. They are very the sophisticated labs. And in order to exit BSL4, the persons who are working, so they have to pass through a chemical shower for decontamination. Then uh, of course there is a separate room for removing a PP or suit, and followed by a personal shower. So you can see like how advanced or like sophisticated settings we need for this BSL4 level labs. Entry is restricted, of course, and also the airlocks are also needed, and these labs are actually isolated from the main buildings. And also all lab waste, including filter air, water, trash, must also be decontaminated before it can leave to the facility. So these are the very sensitive labs. So risk, and also this type of lab BSL4, according to my knowledge, I think is not available in Oman. So BSL we have until BSL3, but we don't have even in ministry. So we have only BSL3 level labs in Oman, but we don't have BSL4. So in this case, you can see the workers those are working in BSL4 labs. So kind of these you can see their PPE is very different and very sophisticated. The microorganisms, the pathogens, those are fall under BSL4 are, for example, COVID-19, Hydra virus, Nipah virus, flaviviruses, and varroa viruses. So these are, for example, varroa virus is the causal agent of smallpox. So they are very dangerous and very, they can cause the disease, or even most of the time they cause the death to the persons who are working if they got infections. As I mentioned in the previous slides, the pathogens those fall under BSL4. So no vaccination is available for those pathogens, and the only way that we can survive, or we can stop the disease, or so we can plan like the disease cannot spread further. So the isolation is the biggest the tactics that can be used to stop the disease. So it can be effective method if the hazard job can be moved to a part of the workplace where few people are exposed. So like in nowadays, we are facing COVID-19 and social distance isolation. So these terminologies are very commonly using, right? And of course, all over the world, social distance and isolation and quarantine. So every country is trying to make people separate so that the disease can be stopped and minimum, the losses can be done by you from this COVID-19. And of course, the ventilation. So ventilation can be used for two reasons, for two purposes. For example, the one is to prevent the environment, working environment, from being too hot, dry, cold, or dry, or humid, because of course different pathogens they use they have their requirement is like different according to their nature, like temperature or humidity. So that's why we can use also ventilation. And secondly, to prevent contaminants in the air from getting into the area where worker breathe. So especially like in a different lab settings. So in this picture you can see, for example, this is the source where is a the contamination or spread out, and you can see like this is the air path and how like it goes to the persons or the workers. So whenever they take the breath, right? So during the breathing, so they can of course take and this is since this is if we provide like this is a the ventilation area, so then there are chances like the air can be at least somehow it will become not too contaminated as it is close into these areas. Other control methods that for especially for these BSL-4, although this can also be used for other levels. For example, general cleanliness, like we are using the personal hygiene, and of course while we were working in the lab, so never pipe it by mouth, do not consume lab ice, deionized water. So these are the two uh, things or the material that's actually confusing mostly. So sometime if somebody need ice, deionized water, okay, and sometime maybe sodium chloride. So in emergency some people need any ice or deionized water, so they sometimes use actually. So that's why this is not good. No eating, drinking, of course these are the general, and also wash hands before leaving lab, as well as so this is nowadays it's very common practice, even although everybody is doing before, but this is especially like now. This picture showing a safety pyramid, and it contains different levels. For instance, the first level is about the safety awareness, where we can get all the informations. It means like this is the basic step or the first step, that whenever we start working in the lab, we need a full awareness. And secondly, near miss or hazard recognition. So this is really very important. If we know or we can recognize the hazard, and then we can deal that hazard according to the precaution or according to the SOPs of that particular hazard. And the third pyramid, the step is a minor injury or first aid. This is if something happens, so this is like minor. And the upper level is recordable injury. So for example, if somebody got like this a higher injury than the normal, so if this is recordable, mean like it should be discussed within the lab or the department or whatever the RMO office, okay, so through the technician or the administration, because this injury will help us for the assessment of the particular the environment, the working environment, okay. And the upper level is the lost time injury, okay. So of course after that this is a more dangerous, there are very critical, okay. So this is just showing like about the safety pyramid. In total safety, these levels are very important for to highlight the benefits of the safety. And in the last figure, I just mentioned word near miss. So near miss is actually any incidents or unsafe condition, so with the potential for injury that is normally like happen in the labs. Okay, but what is the severity of the near miss? That's we mentioned in the different levels. You know, it's minor, then it's if it's major, and then there are different levels of injuries. And okay, so only a fortunate break in the chain of events prevented injury or fatality. So this is about like how we can get a total safety culture. So this is a very small or very short lecture, a topic about the biosafety levels, and so I hope you can have now idea about like a different how different microorganisms or biopathogens have been treated into the different labs according to their nature of severity. Okay, so in Oman, so we don't have BSL 4 labs, we have only BSL 3 labs, and the students or the especially like our university, mostly the undergrad students are working in BSL 1 or maximum BSL 2 labs. So it's not like very dangerous pathogens, not microorganisms are not very dangerous, but of course like if you're working in the College of Medicine, so if you're dealing with blood samples, then it's another story. Okay, so the otherwise overall our labs are like BSL 1 or BSL 2, so it's not very dangerous, but of course if you know like all this information, then it will be helpful for your safe working into the different labs. So thank you so much, so see you then, bye.